Awesome. Wayon, I really love that song. Like rather the music.
Thanks. Yes, that's one of our more the soundtracks that one of the ones we like the most. I think we used it for a few times last year. Hey
Yeah.
Shafras, how have you been?
Being good, being good. Being busy, working from home for a long time now. I'm waiting to go back to office. How about you, Wayan?
Uh, well, talking about office, I'm actually in office right now. You can
Oh
see
wow.
the background over here. So I think
Yeah.
everyone has left for the day.
Yeah.
But I mean, we're here today for a very, very exciting event, very exciting topic from a very interesting speaker. So I'm
Yeah.
very keen to hear this topic later on.
Yeah. Same here. Same here. Very interesting topic. Not a lot of people talks about this as well, but keeping up with the trends, keeping up with the momentum that we see in the technologies, I think this is pretty relevant.
So I think today has is kind of interesting. I think the last time we did this webinar, I think number 13, we were sort of running it as our own group, but today we're actually doing it with Dev Space as well. So you all can see on the screen as well. We're actually featuring the Dev Space, dash sg.dev. So yeah, maybe you can tell us more about this.
All right. Cool. Thanks, Rayon. So, on behalf of the developer space team, I'm actually down here to tell you a little bit about the whole event and also about the developer space as well. So, my name is Shafraz. I'm part of developer relations team here in Singapore office. So, before we begin in today's session, organized by GDG Cloud Singapore, Wei Yuan and Harizuan in the backstage as well. Let me briefly introduce what we do and who we are as Developer Space Singapore. Google Developer Space is a platform for developers and startups around the region to learn and connect with one another. As part of developer relations team, we aim to empower and connect the community to our people, programs, network, and technologies. So we are really excited for this awesome session today on machine MLOps. And we have like an amazing speaker, a very well-known speaker as well, joining us with us today. But before I hand over to Wei Yuan on to hand over to take the proceedings further, let me give you two announcements around events upcoming by Developer Space. So the first event is around, all right, International Women's Day. So we all talk about diversity. We all talk about why it's important to have more diversity in technological companies or maybe and then also like societies, etc. With So International Women's Day holds a significant sort of a key day on the 8th of March. So the developer space team, what they did was they thought, hey, might as well we collaborate with more communities this year so we can host a larger or maybe a month long or a couple of weeks long activity series upcoming. So if you go to this link, which is gwo.gle/IWD 2021, you'll be able to see what are the communities which has come along to this particular event series and what are they are talking about, what when are their events are happening, etc. So you can go and get more information from this link that I have mentioned over here. And the second event that we want to talk about is the Flutter Engage Extended Southeast Asia. It's pretty interesting. Some of you might have been listening to Flutter Engage yesterday, and Flutter team announced about Flutter 2.2 as well, which is pretty cool. If you have seen that in the announcement, you might have seen it's now available for web and mobile, and then a couple of more new features that they have included as well. That's pretty interesting. So what we thought to do was, hey, why not we speak about this regionally? So this is a regional event where you get an opportunity to listen from our Google developer expert on Flutter, and also there'll be a software engineer joining in to this session from the Flutter team itself as well. Please do not miss this chance to be a part of this event. You can go and register yourself from gwo.gle/Flutter ACA. Go to that link so you can get more information and register yourself. So this event is happening on 10th of March, 7 p.m. Singapore time. So those are two announcements that I want to mention. And it's going to be a long day, a lot of information, a lot of important information for your company, for yourself as a developer as well. So without taking much time, I would like to hand over to Heya.
Thanks, Shafras. It's really awesome events that are coming right up. Definitely very excited as a developer. I think segueing to a very related event. So I think Shafras talked about IWD, and the great thing is that GDG Cloud Singapore, we're going to be part of that as well, and we're going to have on the cloud IWD edition. It's going to be something to do with pies. Take that hint what you will. Going to be a really fun topic. Maybe something to do with baking. Who knows? But definitely pies. So definitely watch out for that. That's going to be on the 27th of March 2021. So 27th of this month. Yeah. Right. Okay. Let's go to the next. Okay. So let's go on and talk about why are we here today, and very, very exciting topic. What's up with MLOps? That's the theme of our event today. Okay. Topic itself, is going to be presented by developer advocate from Google Cloud, Kaz, who's going to be talking about MLOps and Cloud AI. So for those who have tuned in to Cloud Next from last year, MLOps was one of the key topics they talk about in the weeks where they were referring to ML. And I think this is a very, very important topic, especially if your companies are looking into using ML itself, you want to have this as part of your workflow. So I think without further ado, let's invite Kaz onto stage.
Hi.
Hi, Kaz. How are you doing?
I'm good. How about
Awesome.
you?
Yeah, I'm doing good as well. So yeah, I think I'm going to switch over slides to yours.
Mm-hmm.
Okay. And yep, the stage is yours.
Thank you.
All right.
Yeah, thank you for inviting to the great community. And let me introduce myself. I'm Kaz. I'm a developer advocate of Google Cloud team. I have been working at Google for over 10 years. For last 6 years, I have been working as a developer advocate, focusing on the cloud AI and machine learning projects. And I went to Singapore less than 10 times, but over 5 times. And I had like 4 or 5 community events in the past. So I suppose some of you might already watched some of my past sessions. So I'm glad to come back to the Singapore community again. And I really hope to, physically come back to Singapore anytime, maybe next year after the COVID-19. I really miss the city and the foods and everything, the office. So yeah, I'm happy to meet you online again. But anyway, this time I'd like to discuss about the MLOps and what's happening with the MLOps updates with the Cloud AI platform. So these are the topics. I will start discussing about what is MLOps and what has been the MLOps practices we have learned at Google for the last 20 years. And I will quickly introduce the AI platform, which is the cloud service from Google Cloud. And then I will introduce the practices, how you can use, apply the MLOps practices with the tools from the AI platform, especially AI platform pipeline is the very important tool for the MLOps. And then you can ignore the 4th steps. I'm reusing this slide for the other workshops, so I will skip the workshop part. And then I will discuss about the future roadmaps of the MLOps products from AI platform. So MLOps at Google. So I'm keep using this slide for last 2 years whenever I talk about MLOps. I started talking about MLOps since 2018, the next San Francisco event. And because I had a meeting with some of the software engineer at Google, at that time, like 2 or 3 years ago, who has been designing, building, and operating one of the largest machine learning production system at Google for over 15 years. And he said this word, the launching the machine learning system is the easiest part. And the hardest part is keep operating that machine learning system for like 5 years or 10 years and more. Especially when you are putting the machine learning into the core part of the mission critical system of the enterprises, then the things are really getting hard. The real problems with the machine learning system will be found while you are continuously operating it for the long term. So this is the famous diagram where you have the machine learning the model in the center of the diagram, and that is surrounded by all the other parts required for building the production machine learning system. Like you have to think about scalable way to data collect those training data. You have to build the serving infrastructure. You have to think about feature extraction. You have to make sure that the training data is healthy and doesn't contain any contaminated or the bad data or distribution. Monitoring, the process management, resource management, everything. So this is the problem for the MLOps. And I sometimes use this metaphor of for example, for making a cookie, or if you are making a cookie factory, that's the difference. So if you are a good cook, then maybe you'll be able to, or maybe patissier, you'll be able to make some good, delicious, tasty cookies for like a couple pieces. But what if you have to keep producing the same cookie, like hundreds of the pieces of the cookies every day for thousands of people? So you need to build a factory. So you cannot, everything should not be dependent on yourself. Instead, you have to build a scalable, reproducible, available factory that can keep producing a high quality cookie for everyone. So that's the difference between the ML and MLOps. So, but currently in many cases, the many enterprises has been working on the machine learning POCs, the point of proof of concept projects, where everything has been isolated. Like data scientist has been doing their own work with their own workstations or the notebook environment. And once they got some pretty nice model trained with the testing data, then they would just pass the trained model to the IT department, where the ops engineers should be responsible for building the serving environment. So usually the things are isolated. And that's exactly the same situation we had in the web industry in like 10 or 15 years ago, where there were no practices for the DevOps yet. So many software engineers used to build their own application code, write their code, and just pass those code to the ops engineer. But if you have any serious problem on the production system, the ops engineers don't have the way to rolling back the system to the healthy status, or the finding the problem by using the monitoring system, or the rebuilding the system again and again. So that has been the problem solved with the DevOps, the practices in last like 15 years. So the idea is very, very simple. We can bring the same practice of DevOps into the machine learning production system. But the thing is that it's not that simple. So at the right side, you can see all the challenges for the DevOps. Like you have to build the scalable, available, and portable infrastructure. Maybe you could use the Kubernetes or container technology to do this and make everything reproducible by writing some Docker file or anything. Modularity, monitoring, alerting. So those are all the DevOps problems. But the thing is not that simple. Those challenges are tightly connected with the machine learning challenges. The challenges that are very unique to the machine learning problems. For example, you have to think about the governance on the many artifacts. Artifacts is something called artifacts, including the data for the training, the raw data on the data warehouse or storage, or features. Features are some refined or cleaned up data that is ready to be used for the training the model. So everybody's machine learning data scientists are doing the feature engineering to data to do the data cleansing on the raw data, extract some features by feature engineering. So those are the features. Models by training the models. Pipelines are used to continuously training the models again and again. And experiments or all the trial trainings and feature engineering is done by the data scientists. So in the past, those things, we call them as artifacts. Those artifacts are not managed well or didn't apply many enterprises didn't apply good governance on managing those data, features, models, pipelines for sharing them with the enterprise scale. So that has been one of the biggest problems for the machine learning, the productionization. And also, obviously, CI/CD is also required for the ML systems, continuous training and deployment. Training serving skill is the difference you would see when you train a model with your notebook or development environment, but when you bring your own machine learning model to the serving environment, somehow it happens to have some degraded the accuracy or the KPIs. So, and that could be happening by any slightest the causes, right? Slightest changes in the way of the pre-processing or feature engineering by the ops engineers, or the slightest change in the input, the feature distribution in the input training data. So anything can affect badly to the result you would get from the machine learning model. That is, we call it the training serving skill or just skill or drift. So you have to think about the monitoring those skills and drifts in the production system. Data validation is very critical. I will be discussing about this later in detail, model analysis. And this would take another session to talking about fairness and explainability. So if I could have some time, so maybe I can briefly take a look at that, share some slides for the fairness. But fairness and explainability for the AI and machine learning system is becoming another hot topic in the industry, and it's not so easy problem to solve. So those are all tightly connected, entangled with those DevOps challenges. This is the unique challenges for the machine learning systems. And as you know, the Google has been, getting revenue by using machine learning algorithms for over like 15 or less than 20 years. The almost 80 or 90% of our revenue has been coming from the Google Ads. And Google Ads uses machine learning at the core of the systems for less than 20 years. So we have been struggling for solving these production machine learning systems problems for over 20 years. And we have been publishing those practices as the published papers and documents, like TFX papers or the machine learning papers, technical papers, and so on. And now people are calling them as MLOps, a new buzzword in the industry. People started to use in last 2 years. But as I mentioned, those challenges for the machine learning MLOps has been solved. We have been struggling to solve these MLOps problems for last 20 years. It's all about unifying the machine learning system development with dev and ops. And by dev, it means the data scientists and the researchers. So not only the application developers, the data scientists and the researchers should be get together with the ops engineers by removing the isolation to build the available and scalable production factory for our cookies. So that's the idea of the MLOps. So now I'd like to introduce a product called the AI platform from Google Cloud. So this is going to be an AI and the platform for the data scientists and ML engineers and ops engineer for implementing the MLOps practices. So before diving into the MLOps itself, I'd like to quickly browse all the products from AI platform. So this is the big picture of the AI platform offering. And application could be the vision analysis, video analysis, or conversations like a speech synthesis or speech recognition, or language natural language processing. And also you can use the AI platform for analysis on structured data like a tabular data. So those are the applications, and those applications can be be very easy challenges, or maybe it could be in hardcore data science kind of problems. And AI platform provides a different variety of the core products to provide a solution for different kinds of the problems, easy problems or hardest problems, including the notebook or data labeling service, or the experiments, metadata store, AutoML training, explainable AI, feature store, and so on. So by combining these components or core products to solve your problem, you can build a scalable and available platform for development and deployment of the machine learning system. So rather than using your own on-premise GPUs, the server with the software stacks installed by yourself and maintained by yourself, you can use the standardized AI platform environment for large-scale deployment of the machine learning development environment in enterprises. So you can get the higher productivity, reduced learning curve, because all the software stacks should be standardized with the same versions of the NumPy, scikit-learn, or the CUDA drivers, or TensorFlow, PyTorch. Everything can be easily standardized with the virtual machine images or the container images, and just click some buttons to create a new notebook instance with the standardized software stack. And also it's makes it super easy for repeat the experiments with the notebooks and the AutoML, everything. Seamless integration with all the other Google Cloud products, especially the BigQuery is the most attractive the product for the data scientists. The super fast, scalable data warehouse. And MLOps is the topic I will cover today. So not only the data scientists, but also all the other responsibilities and roles like product managers, data engineers, or ML developers, or ML ops engineers, or just pure ops engineers. Everybody can share the same platform and share the same artifacts like raw data or features and models and pipelines and so on, so that you can remove the isolation we had in the past. And if you are a data scientist, maybe the AI platform notebooks will be the standard, the dashboard for you. Not dashboard, it's a notebook environment, Jupyter notebook running on the Google Compute Engine instances. And many people have tried the Google Colab or Google Collaboratory as the easiest way to get started with the cloud-based data scientists. But the Google Collaboratory is a free service. You cannot get any technical support for the Google Collaboratory. Actually, Google Collaboratory is built and operated by the Google research team, not by the Google Cloud team. So it's not a commercial service. It's a kind of experimental, the free service. So if you're in some commercial projects in the enterprises, the AI platform notebooks is definitely the recommended service for you. You can choose any types of the instance to run the notebook. So you can start with the one virtual CPU, or if you want, you can just put 16 A100 GPUs in a single notebook instance. You don't have to, call to the NVIDIA people and buy the super expensive GPUs, supercomputers that has the price tag something like, how much is it? Like $400,000 if you want to put the 16 A100 into GPU server. It's pricey. It's super expensive. But with the AI platform notebooks, you don't have to pay any initial cost. You can just, you can just start your instance and shut down instance as soon as you finish your training job or anything, so that you can just pay for the computation power you have just used. So that's the good point, you benefits you could get by using the cloud power. And also you can easily access to the other Google Cloud tools like a BigQuery, Dataflow. Those are tightly connected, so you can easily execute the SQL on BigQuery from the notebook, and you can get the highest performance for downloading the result set from the SQL, convert it into your pandas data frame in the notebooks, and do your analysis at local. And now we are trying to unify everything into an AI platform. So in the past, we have provided multiple different products, like the AI platform training. This is a distributed training environment, managed training environment with the like 1 to 2 to 3 to or maybe tens of GPUs running in parallel for the large scale distributed training. And there are some other options for you for choosing the training environment. For example, if you just want to, upload your images or the videos to the Google Cloud and get the fastest possible result, the training model with for that, the images, then AutoML could be the best tool for you. So as you might already know, the AutoML is the one of the easiest way to customize your own machine learning model. And you don't have to do everything by yourself, like data augmentation for the images or hyperparameter tuning with the multiple experiments running in parallel. Everything has been done automatically. Actually, AutoML Vision uses like a 90 parallel workers or nodes working on the Google Cloud to do all the experiments running in parallel with the different hyperparameters and different the network design with the network architecture search. So anyway, you can just upload those data on the AutoML and press the training button and wait for like 6 hours to 24 hours to get the machine learning model. And now the AutoML is tightly integrated with the AI platform itself. So you can easily deploy the model to the AI platform prediction at the right side, so that you can build the scalable and available prediction and serving environment that is based on the Kubernetes engine running behind the scene. And also some other interesting option is BigQuery ML or BQML. Now BigQuery supports the ML syntax to train your own model inside BigQuery with the SQL. You don't have to run Python to train a model with BigQuery. The limitation is that the BQML only supports a number of the simple models, like the linear model or simple DNN, MLP, or XGBoost is supported now. Or you can import the external TensorFlow saved model into the BQML and use that for the prediction. And what else? And you can also run the AutoML tables trainings from BQML SQL. But anyway, the BQML is not the silver bullet, and you cannot solve all the problems with BQML. But if your problem is fit into the BigQuery ML, this is the most powerful, and easiest way to train your model, especially for the large data sets like hundreds of terabytes or maybe petabytes of data. Because it's a BigQuery, it runs with the thousands of CPU in parallel. Your machine learning training job is also running with the hundreds of the machines in parallel. So you don't have to think about the memory size of your own pandas or Python instance. So every data scientist is trying to put everything into one huge memory, like a 4 gig or maybe 8 gig or maybe 16 gigabyte of memory to do everything inside the pandas data frame. And with BQML, you don't have to do that, because it will be using the hundreds of the machines running in parallel for training the model. Usually, you don't have to think much about the memory outage. And again, these machine learning models can be easily exported and deployed on the AI platform prediction at the right side for the production, the serving use cases. So those are the quick introduction of the AI platform right now. By the way, if you have any questions, please, throw your questions so that I will try to answer those questions afterward. So now let's get into the MLOps with AI platform pipelines. This is a quotation I copied from the some papers, machine learning technical paper written by the Google Ads team. That paper says, at Google, a hybrid research approach where engineers and researchers are embedded together on the same teams. And this has helped reduce the source of friction significantly. So in Google, the isolation between data science and IT is not recommended. It's things you have to avoid. Instead, the researchers, data scientists, and ops engineers should be embedded together. It doesn't mean that all the ops engineers have to understand what's going on inside the machine learning model or the Python or TensorFlow code, but at least they have to share the artifacts like a training data or feature data, or of course the TensorFlow or PyTorch code should be shared, and everything should be shared so that they can work together to solve the production level problems. Another the rules I have quoted are the rule number 16, plan to launch and iterate. So this is the CI/CD principle we can bring from the data DevOps practices. So every single machine learning models should be able to be retrained anytime, hopefully by any person's hand. So it should not be dependent on your own, personal skill set or knowledge. Everything should be reproducible by any person in the team. So you have to start planning the whole machine learning production system to launch and iterate the model with the retraining the model again and again. And to do so, you have to define what's the freshness requirements of your machine learning model for a particular business requirement. That differs. That could be different based on the requirement from business. For example, if you are training some, for example, speech to text model or text to speech model, then maybe you don't have to retrain the model every day because it's really hard to correct those speech training data or labels or annotation data. So usually maybe the training iteration period could be like maybe 1 week or maybe 1 month for the experiments anyway. But if you want to build some recommendation system for the EC site or maybe news aggregation website, maybe you want to retrain the model again and again in a day. For example, I know some of the news aggregation site in Japan, they are retraining the model every 5 minutes with this Spark streaming the infrastructure. So that's the fastest retraining the timings I've ever seen. But yeah, thing is that you have to change the refreshment requirement based on the business requirement and define that. And you have to detect the problems before exporting models. So you have to do possible the validations against the training data and the training model. You have to check the fairness and biases and explainability before deploying the model to the production system. Otherwise, if you don't do much validations against machine learning models, it's just like you are pushing the code with many bugs inside it. So you want to avoid that. So applying those the practices, we provide the product called the AI platform pipeline. This will be the foundation for the MLOps practices on AI platform. So basically, it's just a job controller. It doesn't have actually, it itself doesn't have any of the machine learning training or anything. It's just a job controller like Google Cloud Composer with the Airflow or like that. So it's a job controller specifically designed for the machine learning and MLOps practices. So for example, if you want to design a pipeline for the continuous training and continuous deployment, the model to the serving infrastructure, you can easily use the GUI of the pipelines to define that pipeline. And the thing is that you can get the higher reproducibility. As I mentioned, the reproducibility and portability is the key concept in DevOps, and you have to do that. And audit and governance could be will be a much larger problem in next like 2 or 3 years, because every enterprises are trying to bring the machine learning into the core part of their business. Their core part of the business IT systems or mission critical systems. That means the auditing and governance is very important to think about. Especially on the artifacts, like the raw data for the training data, features that is gathered with and collected with the feature engineering models you have trained, and the pipeline design itself could have multiple versions, and experiments, every experiment done by the data scientist should be shared and governed by some shared practice. And every other data scientist or every other ops engineer should be able to take a look at what's going on in the features that has been created by the feature engineering with some other data scientists, or what's going on with the pipeline you have designed, and what are the differences between the accuracy you got with yesterday's pipelines and today's pipeline and things like that. And you have to make everything explainable and audited. And who does that and who did what, that kind of things should be logged. And the AI Platform Pipeline provides the foundation for that. And everything is not the black box on the Google Cloud. Everything is implemented as the open source tool, managed and hosted open source tool running on the Google Cloud, the virtual machines. Like the Kubeflow pipeline is the one of the open source tool we are using for this, and another one is the TensorFlow extension. TFX and Kubeflow pipelines are all open source tools with SDKs, so you can easily customize those source codes by yourself. So in many cases, many customers want to customize the code to adapt to their existing environment. Like if you have the on-premise devices, you already have some GPU servers, or you would have some mobile devices, and you would have some proprietary network, private network. Maybe you may want to add some tweak into the Kubeflow pipelines to have a tighter integration with those existing on-premise or private network, so that you can have the AI platform pipelines running on the cloud, orchestrating everything, including the on-premise devices, and pushing the TensorFlow write model into the Android devices and iOS devices like that. And also, what else? Many customers asking me that, but everything should be dependent on TensorFlow, right? But they are not. The AI platform pipeline itself, and the open source SDKs like Kubeflow pipelines, and even TensorFlow extension itself is free from TensorFlow. It's interesting. But TFX, some part of the TFX is dependent on TensorFlow, but some other part, like a data validation component in TFX, which I'll be talking in detail in the latter part, is not dependent on the TensorFlow. So even if you're a PyTorch user or scikit-learn users, you can easily apply those tools for applying the MLOps practices with the XGBoost and PyTorch and other tools. And another interesting feature, I will be showing some live demonstration after this about one interesting user interface and functionality is the Lineage Explorer. So where you can actually check what's the lineage or the dependency between all the different phases of in the data process pipeline. For example, if you have a model, then that model should be trained with some training training code, and you can easily track that with the metadata store. So everything, those artifacts, metadata are stored on the metadata store embedded in the AI platform pipeline, and that will be shown. That will be shown on the Lineage Explorer user interface. I'll be showing the actual demonstration later. So, so by using this AI platform pipeline, you can build the machine learning lifecycle management. You are starting from the extracting data from data warehouse, BigQuery, Google Cloud Storage, and other data storages. And then you can apply the data validation and then feature engineering and train the model with the AutoML or the AI platform training, evaluation of the model, validate the model, and push the model to the serving infrastructure. Everything is managed, can be managed by the pipelines. With the integration with the other Google Cloud products like BigQuery or training, data flow, prediction. So naturally, all of those components and services could be scalable and available without spending much time on building your own cluster for the Kubernetes and installing those training and the prediction and validation functionalities with the container technologies by yourself. So most of those components are managed services provided with the AI platform. So under the hood, we use the Kubernetes, as I mentioned a couple of times. So we use the Google Kubernetes engine, and that runs some pods. Pods are the units of the containers in the Kubernetes. Each pods running those open source tools like Kubeflow pipelines, TFX, or ML metadata store, and so on. But you don't have to much care about the underlying infrastructure. Instead, you can just press a button on the user interface to create those AI platform pipelines cluster on instances, and just use the user interface, and that's it. And some use cases could be experimentation by the data scientist, or retraining, CI/CD, maybe by the ML engineer or ops engineer, model deployment and monitoring by the ops engineers, and lastly, model management and governance could be the important part of the MLOps practices. Those can be covered by the AI platform pipelines. So let's take a look at these use cases. So if you are data scientists or researchers, you can just get started with the AI platform pipelines for for getting higher productivity with the everyday iterative experimentation. So I have seen some of the data scientists has been using some Google Sheet or Excel spreadsheet to managing those experiments by hand, by tracking some of those conditions for each experiments, what version of the data set and what the version of the data hyperparameter set they have used for each training and that kind of thing. And that's tedious work, and data scientists or researchers should not use their time for just for tracking those experiments. Instead, by using the AI platform pipelines, the experiments are tracked by the metadata store, and I'll show that later. And that could be easily turned into a continuous orchestrated training pipelines used by the ML engineers or ops engineers. And model deployment and monitoring. And for example, if you choose to use the AI platform prediction as the serving infrastructure, the pipeline automatically pushes the model to the prediction. And then the AI platform pipelines has the monitoring feature inside it. So, and actually, we'll be launching a new products for the MLOps, like model monitoring and feature stores. Anytime soon. I cannot declare the actual launch time, but it's going to be like some months later. But the existing AI platform prediction or pipelines will be tightly integrated with those upcoming products for MLOps, like the monitoring and feature store. And also, Google has been providing some other open source tool for supporting the other practices like the ML fairness and explainability. For example, model cards or the data cards are the practices we have using at Google. Any AI projects at Google have to put the model cards. That is something like a metadata or manifesto of each trained model. And you can also combine those practices with those AI platform pipelines tools and so on. So we don't have the time for doing the workshop. So instead, I can quickly go through some interesting videos. So this is an introduction of the Kubeflow pipelines. Let's hear some audio.
On top of that, monitoring and version tracking can become a challenge. Kubeflow Pipelines lets data scientists codify their ML workflows so that they're easily composable, shareable, and reproducible. Let's check out how it can help you achieve ML engineering best practices. If you want to check out the documentation directly, check out the link below to read more about Kubeflow Pipelines. Kubeflow Pipelines help drive data scientists to adopt a disciplined pipeline mindset when developing ML code and scaling it up to the cloud. It's a Kubernetes native solution that helps you with a number of things, like simplifying the orchestration of machine learning pipelines, making experimentation easy for you to try ideas, reproduce runs, and share pipelines. And you can stitch together and reuse components and pipelines to quickly create end-to-end solutions without having to rebuild every time, like building blocks. It also comes with framework support for things like execution monitoring, workflow scheduling, metadata logging, and versioning. Kubeflow Pipelines is one of the Kubeflow core components. It's automatically deployed during Kubeflow deployment. Now, there are many ways of defining pipelines when it comes to data science. But for Kubeflow, a pipeline is a description of an ML workflow. Under the hood, it runs on containers, which provide portability, repeatability, and encapsulation because it decouples the execution environment from your code runtime. When you break a pipeline down, it includes all the components in the workflow and how they combine, and that makes a graph. It includes the definition of all the inputs or parameters needed to run the pipeline. A pipeline component is one step in the workflow that does a specific task, which means it takes inputs and can produce outputs. An output of a component can become the input of other components. Pipelines SDK to
sorry about that.
Yeah, pipelines and launch pipeline runs, for example, directly from a notebook. You can also work with pipelines via the Kubeflow UI. That way you can leverage some of its powerful features, like visualizing the pipeline through a graph. As you execute a run, the graph shows the relationships between pipelines and their status. Once a step completes, you'll also see the output artifact in the UI. As you can see here, the UI takes the output and can actually render it as a rich visualization. You can also get statistics on the performance of the model for performance evaluation, quick decision-making, or comparison across different runs. And we can't forget about the experiments in the UI, which let you group a few of your pipeline runs and test different configurations of your pipelines. You can compare the results between experiments and even schedule recurring runs. Because they're built on the flexibility of the containers, Kubeflow pipelines are useful for all sorts of tasks, like ETL and CI/CD, but they're most popularly used for ML workflows. While you can deploy it on your own installation of Kubeflow, a new hosted version of pipelines on Google Cloud's AI platform lets you deploy a standalone version of Kubeflow pipelines on a GKE cluster in just a few clicks. You can start using it by checking out the AI platform section in the Google Cloud console. Kubeflow Pipelines handles the orchestration of ML workflows and hides the complexities of containers as much as possible. You get continuous training in production, automatic tracking of metadata, and reusable ML components. You can clone and iterate on pipelines and leverage the power of the UI to visualize and compare models. Stay tuned to learn more about what you can do with Kubeflow.
So yeah, let me share some of my demonstration. So this is here the user interface dashboard for the AI platform pipelines, where I have already created one instance here. So you can just create a new instance by specifying some the names and regions and those the configurations on the UI, and just click the button. So it's so easy to get started. You don't have to run many commands. And once you get the instance, then you can just open the pipeline dashboard, where you can access the user interface of the Kubeflow pipelines. So this is the UI. This is the Kubeflow pipeline, the open source tool, running on the managed Kubernetes instances. And where you can easily access to the many different tutorials and documentations and demonstrations. And I have already learned some hello world kind of the pipeline. For example, this is the one of the easiest pipeline you can try out on the AI platform pipeline. For example, each component represents very simple data processing. Actually, it's just outputs very simple text to the next component, where the next component only outputs the input text to the standards the output. So that's it. Or this component split the line, text line based on the even or odd of the line numbers and things like that. So if you take a look at how it works with the Kubernetes, not Kubernetes, AI platform pipelines, you can check out the actual run of the data processing. So if you click the navigation menu, you can check out how each executions has been done with some outputs and the result. For example, if you take a look at the repeat line, you can easily check out this is the output text from the component, hello, hello, hello. And the next component just print out this hello, hello, hello to the standard output. And this component splits the text into the even or odd, so 2, 4, 6, 8, 1, 3, 5, 7. So this is a very simple data flow code you can write with this component model. So this is very similar to the cloud data flow, where you can use the Python or Java code to write some data processing. And the difference is that with those components in the Kubeflow pipelines, you can easily call the other Google Cloud AI tools like AI platform training or AutoML for training job for the with the AutoML or training AI platform training GPUs, or you can easily keep the data flow for the large scale, the EKL or data processing job. And so that's the difference between the data flow and the AI platform pipelines. And also, if you click the artifacts button on the menu, you can check out what are the artifacts, like the result you get with each execution of the pipeline, like the model or the features you would get. And you can easily click one of them to check out the lineage between those, the result. For example, the model, this is trained by the XGBoost train component you have defined at this time at here. And so if you click the training component, you can check out the details and the metadata of the training phase, going back to the Lineage Explorer. And you can also check out the some input, the feature data or raw data. So this table, the input data, is coming from this Chicago taxi trips data store. And also this table are used for the multiple XGBoost training the jobs. And that the result in the multiple the artifacts. So this is the lineage of the single run. So with the experiments, you can run many times. You can run the many experiments as you want. So every single runs will be managed and tracked by the metadata store, and you can easily check out the lineage between those, the artifacts and dependencies by checking out this user interface. So this is here where you can apply the governance on all the artifacts or training experiments or continuous training the practices. And also it makes easier for the auditing everything. For example, if you have the one great machine learning model with the highest accuracy, you may want to reproduce the model again and again. In that case, maybe you can use the Lineage Explorer, this user interface, to check out what were the conditions to reproduce this particular model. What was the hyperparameter combination you have used? What version of the dataset you have used for feature engineering? What kind of the feature engineering code you have used? So those are all the things you have to understand, you have to track to make everything reproducible. So that was the Heya platform pipeline. And now we are developing a newer version of the Heya platform pipeline, which is a managed pipelines. That will be another product which will be launched in a couple of months later. So right now, the Heya platform pipelines is running on the GKE with the virtual machines. So some customers don't want to have the GKE virtual machines just for training a lightweighted the pipelines, just for running a lightweighted training jobs. So especially the data scientists for the everyday experiments, having the GKE clusters for that is kind of heavy weighted. So many customers ask us for the serverless the environment for the pipelines. So now we are building that. So the Heya platform pipeline will be a totally managed and serverless environment without having any virtual machines under that. So it's going to be a fully managed serverless service with the super inexpensive pricing definition. Okay, so there will be subtle changes in terms of the functionality you could get with the managed pipelines compared to the hosted pipelines. Yeah, but you can keep using the same Kubeflow Pipelines SDK and the TFX APIs. And lastly, I'd like to quickly introduce the concept of the data validation. This is going to be actually, I don't talk much about the actual products that will be supporting this data validation concept, but we'll be launching new products that is based on this concept, data validation. We want the user to treat data errors with the same rigor and care that they deal with bugs in code. So if you have any unexpected training data in a data set, like, for example, if you have some features like cat images, usually maybe in the development time, you have used many cat images with the nice, pretty cats. But while you are continuously training the models every day, sometimes it happens that you would get some dog images inside the cat data set. And you have to detect that by watching some distribution change of the features. You can have some people to watch out all the data in the streaming processing to watch out the dogs or other animals contained in the cat's data set. But so we have to do that by looking at some statistics values like distribution changes. So that's the point here. And that has the same impact as the writing unit testing or regression testing against the usual IT systems. So with the usual IT systems, people are writing like hundreds of thousands of codes or maybe millions of the unit testing code to make sure that your IT system is working as expected. But are you writing the same kind of the unit testing against the machine learning model? So checking the ROC curve or checking out the accuracy doesn't tell anything about the this smallest glitches, like unexpected behavior in the 1% of the data set. So to avoid the unexpected behavior, you have to check out your training data is healthy and hasn't changed much from the development at this time. And actually, Google Play team got a huge impact by introducing the concept of the data validation. their application install rate, that means all the averaging application install rate of all Google Play applications. I don't know how many it is, like it's going to be over millions of the Android apps. That overall install rate has improved for 2% global, just by introducing the data validation practice. So this is a huge impact for the team. And they are doing that by using the TensorFlow data validation, or TFDV. This is a tool, open source tool. Actually, this is an open source and TensorFlow free tool. So you can apply this tool for the PyTorch or any arbitrary the deep learning or machine learning tools like scikit-learn. But TFDB has been used by the many biggest machine learning setup in Google, like a YouTube team, Play team, and other teams with the petabytes of the training data every day. So let's take a look at how it works. So this is the notebook environment where you can run a SQL or the BigQuery to get the sample dataset, Chicago taxi trip dataset with the trip start timestamps or trip seconds, how much it took for each trip, or what was the cash payment type for each trip, and so on. And by using TFDB, you can easily visualize those statistic values like mean or median, or the maximum or minimum, or the standard deviation, what's the variance. Check out visually on the user interface. And in this case, the payment type consists of the cash and credit card with some the distribution with the histogram. And then you can use the TFDB for detecting some changes of those distributions in each pages. For example, in this case, the graphs, the bar chart with the orange color, the amber color, is the distribution for the evaluation data set, whereas the gray area is the distribution for the training data set. So if you're seeing any difference between the evaluation and training data sets in terms of the accuracy and behavior, you can easily find out that is because there's a big difference in the features distributions. And also you can use the drift and skew detection embedded in the production pipeline. So you can define some threshold for detecting the drift and skews on the distribution of each features. For example, as I mentioned, if there's any cat images, and if you have some dog images in the cat dataset, there should be some changes in the distribution in that feature dataset. So we expect to detect that by using some KL divergence or JS distance to find out the difference between the distributions. And that's the things I wanted to cover. And as I mentioned, we'll be launching a new MLOps product that will be based on the data validation products. And what else? The feature store will be another important product, which allows you to share all the pre-processed features shared by the data scientist, ops engineer, and everybody with this already managed timestamps. So you can effectively avoid the training serving skills. And that's another product. What else? Yeah, there'll be a couple of the new exciting products, so please stay tuned. And if you're interested in those MLOps practices with the AI platform, please check out the pages on Google Cloud, the website. So that's it. Thank you.
Thanks, Kaz. That was a really awesome talk, especially like that the starting analogy that you gave regarding a cookie factory and automation of this. I think it's a really good motivation, for DevOps as well when we are first thinking about automation and all the good stuff that comes along with it. So that's really really great. I think we do have a couple of questions from the audience,
Okay.
so I think we can run through them. Okay, I'm just going to pull out first question by Harizwan. So he's asking what differentiates the AI platform pipelines as compared to other workflow-based systems. So you gave a few examples, Cloud Composer or Apache Airflow, and if there's any special requirements.
Yeah. So yeah, this is a great question. So actually, the AI platform pipelines uses the open source tool called Argo. Apache Argo is a very similar tool as Airflow. It's just a job controller inside it, but that is not the essence of the whole system. So the essence is the practice. So Google has been learning many practices for the orchestrating, the managing, and especially governance on the everything, like artifacts, everything. So the Cloud Composer or Airflow doesn't have that kind of the MLOps practices at all. They're just a pure plain the job controllers. So instead of just providing those tools, we provide the best practices as a solution that uses the job controller for applying those practices.
Okay,
Yeah, one example could be the metadata store. Metadata store is just a plain database embedded in the Air platform pipelines. So that metadata store stores all the metadata of the artifacts, like data or features, pipelines and executions and everything. So that rather than building your own MLOps platform by yourself by collecting the database and collecting using the composer and everything, we provide a solution for the MLOps.
And I think talking about the solution itself, I think Horizon has another very interesting follow-up question related to that. So I'm just going to pull it out. So I think when we talk about managed solution, I think one of the other few key issues is also like pricing, especially like for startups, maybe even big companies sometimes. So what's the pricing going to be like for the managed AI platform? What's going to be priced on? And then he asked about like whether is it the length of time being used to train per model, etc., etc.
Yeah, actually, I myself don't know details of the pricing model they are now preparing for the launch, before the launch. So please wait for a couple of months and for the pricing table, but it will be definitely much inexpensive compared to the existing the pipelines. And you know that the other serverless services from Google Cloud, such as the Cloud Run especially, is super cheap, right? If you run a single job on the Cloud Run, it would cost like a couple of cents. I don't know, less than $1. So yeah, we use the same technology, underlying technology like a gvisor and those the serverless technology. So it's going to be super cheap, but not as inexpensive as the Cloud Run, but definitely much inexpensive compared to the existing pipelines.
Awesome. Okay, we have another question from John over here. So you mentioned, okay, so his question is that you mentioned that the version of data in a lineage view and data validation, how do you define a version of the data, specifically a feature?
Yeah, maybe you have to add some your own practice to do this, but the versioning of the training data is very important concept in MLOps. So by using the AI platform pipelines, you can allow you to any arbitrary metadata or label or tag to the artifacts like data on each the execution, so that you can track what's the timestamp for the data set you have used for the training. So maybe you can manage the versions of the data at the data warehouse side, like a BigQuery or the cloud data storage, or Google Cloud Storage. You should prepare for some versioning to be coordinated with the AI platform pipelines, so that you can have a solutions where you can do all the versioning for the each training and data set.
Awesome
And
suggestion.
yeah, this could be also important. Could be important when we have the feature store. The one unique feature of the feature store is that it allows you to provide access some version controlled data set, feature data set. So the reason why we need that is that some of the training serving skills can be happened by the changes in the data set. For example, if a data set scientist train a model with some older data set, but if you are using some newer data set as a features for the serving the model, then naturally you would see a degraded the accuracy with the model. So to avoid that, feature store provides some snapshots or the versioning of each features. So if the model itself is the trained at the, for example, yesterday, then it automatically provides the features at the generated at yesterday, not the latest data. So that kind of the things can be a good result in avoiding the training serving script.
Okay. Okay, we have another question over here. So actually, this one came from me. So I think you actually just now introduced 3 rules and that you talked about. So I went to search on it on Google and I found out, oh, there's 43 different rules, and I think for any team, right? So 43 is a really big number. How do you, let's say if you start doing ML ops, how do you make sure the team keeps to all this like 43 different rules, make sure things are efficient and all that?
Yeah, these rules are not the strict rules. You have to apply them all. So these are the practices or patterns. So it's just like a design pattern or anti-patterns. You have to watch out for the entire project.
We have another question from Harizon. So he's specifically asking about CI. So it's a very interesting question. In fact, how does one run CI checks on the ML model? What does it exactly do you test, for different models?
Yeah, so the data validation could be a replacement for the unit testing. For example, in some cases, it's really hard to get the ground truth at the time of the serving. So the ground truth cannot be used for the checking the result. In that case, all things you can do is you're checking the data itself. So if you are making sure that all the distribution for each features hasn't changed much from the original distribution, then you can say that the behavior of the machine learning model hasn't changed much. So actually in the future products, we launch a new product called model monitoring, which will be using the TensorFlow data validation TFTP embedded in the model monitoring product to apply the skew detection, drift detection for the serving the prediction the part. And for example, it keeps tracking. For example, for every 1 minute or every 5 minutes, it runs some testing prediction against the environment and check out the distributions or the serving features.
Awesome. Okay, so I think that's all the questions we have. Okay, maybe one more from B, which is I think the slides itself are very informative. Is there any way we can get any of this information? I think, like, for example, I think that there were a few links from the previous slides as well. So I think there were a few videos. So is this published somewhere that maybe we can take a look at those?
Yeah, actually, this slide is not published, and I cannot unfortunately share this slide. But there's some weird rule in Google. Traditional rule in Google is that you cannot share the slide, but we can share the video. So if this is a recorded video, then you can just check out the video.
Awesome. So yeah, for the audience who are watching, so this is the video. So this is a live stream, but later it will be converted to a video in our YouTube channel. So yeah, if you want to look back at the content, you can just go through the video again. All right, so I think, yeah, that's all we have today in terms of questions. Once again, Kaz, that was a really, really informative session. Thanks for spending your time with us and sharing with our audience in regards to your knowledge and expertise here.
Yeah, thank you so much for for inviting me.
Thank you, Kaz. Right, so let's get back to before we end today with a few announcements, and some of you might be actually waiting for the updates on one very exciting thing that we have in the coming weeks, in fact for the entire month itself. So let me add this. Okay. Right, so what are we going to have, in the coming month or so? Some of y'all might be familiar with, the modular GCP. We've done this 2 times, season 1 and season 2 last year. Okay, season 1, I think, was actually around the same time this year. Season 2 was around September of last year. There were many interesting prizes, and it was really great. You get to learn more about GCP and get, some swags along the, while doing this learning experience. And so what is there to know about this, modular GCP? Okay, I'm going to go back to the last slide again. If you need more information, you can just note down this link over here, go.gle/modular GCP. Okay. Okay. So this time around, for modular GCP, the theme is going to be about infrastructure and application development on GCP. Okay. There's going to be a total of 18 recommended quests. Okay. So for all the quests that you have completed within the time period of 6 March to 4th April, as you see over here. So this would be what's considered as the eligible quest that's completed that you can submit for getting those swags. So you need to make sure that those quests are only completed within this time period. All right. Okay, so just to give a bit of hints of what's to come. There's different swags. In fact, some of those are really impressive. Like there's this temperature LED display, thermos flask. There's also some interesting ones like the apron. If call back to if you are managing Docker images for your company, baking images, you have an apron for doing that too. And yeah, very, very interesting swags. Polo t-shirt as well as the back over here, as you can see. The hipster backpack, in fact, is written here. So similar to our previous seasons, there's 2 tiers. The first tier itself, you just need to complete 6 quests. Second tier, 12 quests. Okay. So once again, only quests that are completed within 6 March to 4th April. So if you start today, right? Today is just 4th of March. Those quests will actually not count. So once go and register first. I'm going to show the link again. Go and register at this. There'll be a link at this site. Register first, wait for the instructions to come in. Once 6 March comes around, you should be able to get some access to trying out this quest in Quick Labs. And then from there, you should be able to, learn more about GCP, get the swags at the same time as well. Okay. There's also another exciting event. So as we introduced at the earlier part of the this event just now, we're gonna have another very exciting talk, 27th of March, nearing the end of this month, is together with in line with all those IWD events that we have, International Women's Day, as you all know. And yeah, again, the hint is something to do with pies. Not okay. I'll just say not really to do with baking, but to do with pies. Maybe some of y'all would know why is it already. We'll review the the details of this event in due time. So yeah, stay tuned for that. And yep. With that, usually we always want to ask for speakers from our audience, and if you have something exciting you want to share with the community, we always encourage you to step up and let us know. We'll try and schedule you in and get you to connect with our audience. It may be something innovative you're doing within your own company, maybe something you're doing, some open source project or something you're doing as a side project. Do feel free to share with us. We'll review into it and we'll get back to you on your CFP. Okay, so yeah, GDG, SG, CFP. Okay. Oh, sorry. So yeah, with that, I think we have come to the end of today's session. So make sure, you like, share, subscribe our stream over here. And yeah, let us know, within the comments if you have any feedback or anything. So with that, see you guys next time.